Welcome to Researchers Come. In this program, we introduce the researchers from all over the universe. So today's researcher is Dr. Shigehisa Takakura in Academia Sinha Institute of Astronomy and Astrophysics of Taiwan. Nice to meet you, Dr. Takakura. So let's start the interview. First of all, could you tell me what kind of research you are doing now?
My primary research now is star formation. Star formation is to study how stars form in interstellar space. And in interstellar space, there are cloud of molecular gas.
Cloud of molecular gas.
Yes, and we call it molecular cloud.
Molecular cloud.
And molecular gas can condense to form new star in molecular cloud. That's
the process of the star formation.
Right.
Okay.
And that's what I'm now studying.
Okay. And how do you carry out the experiment?
Okay. I'm mainly observing molecules in molecular cloud, and in molecular, those molecules can emit radio. And with radio telescope, I'm observing those molecules, and then I can study molecular cloud and star formation.
Okay, by measuring the radio from the molecule. Okay, and I hear that you are participating in some very big project to make some telescope.
Right. Now we are constructing a big radio telescope, and the name is ALMA.
ALMA.
Yes.
Okay.
ALMA. Right. And now we are trying to observe sub-millimeter molecular lines. That means the wavelength of the molecular line is shorter than 1 millimeter.
Okay.
Yeah. And you can study warmer molecular gas with sub-millimeter molecular lines. And that means you can study very close to your star, and then you can study how planet form around stars.
Okay.
So that is why ALMA project is important to study star and also planet formation.
Okay. Okay. Understand. Thank you. So let's move to the next topic. Could you please tell me what kind of research you can give to other researchers if you do some collaborative research with them?
Okay, so what I'm observing is basically molecules in interstellar space. So the condition of interstellar molecular cloud is quite different from the condition on the Earth. For example, the gas temperature in molecular cloud is around 10 Kelvin, which is quite low.
Very low.
Right. And also the gas density is very low. But on the other hand, we know that there are many molecules in such an extreme condition. So, and we know some chemistry in such condition. So we can provide such kind of information. What is a chemical chemistry in such an extreme condition?
Okay.
And also that kind of physics in such extreme conditions.
Okay. And do you have any other resource?
Yeah. And also we are using radio telescope. We have to know that equipment, that instrument. For example, we have to make an image of your astronomical object with radio telescopes. And actually, the technique to make an image of object is kind of difficult. I'm sure that I can provide some technique about imaging. Imaging technique.
Image processing.
Image process. Yeah, that's right.
Okay, it can be applied to a lot of
that's right.
fields.
Right. Another thing is we have to control the telescope. So we have to invent the most efficient controlling way to get the best image. So we can provide our controlling technique to other people like robot.
Okay. So let's move to the third topic, your future research team. I'd like to know what we are going to do after the ALMA is constructed.
Okay, with ALMA, you can study a very finer structure in molecular cloud, and that means very close to the forming star. And also around the forming star, there must be a planet formation around the star. So with ALMA, you can study how planet form around the star. So that means we can study how planetary system, like our solar system, can form.
Okay. And here that you have one hypothesis. I think this shows your hypothesis.
Okay, so
could you just tell me about?
Okay,
this is
that is my idea. This horizontal axis shows the velocity of molecular gas in molecular cloud.
This horizontal axis. Okay.
Right. And vertical axis is radio intensity.
Radio intensity.
Yeah, which is proportional to the amount of gas, of molecular gas.
Okay.
So the solid curve shows observed observational result with current radio telescopes.
Okay.
And what is interesting here is that the width, in the horizontal axis, and the velocity width is quite wide.
Wide.
Yeah, as compared to the dashed curve. The dashed curve shows a kind of theoretical curve of the molecular gas in molecular cloud. Since the kinetic temperature in molecular cloud is considered to be around 10 Kelvin, so if the internal gas motion is just thermal gas motion, the observed signature should be the dashed line. But in fact, our observation shows the solid curve.
Yes.
So what is this difference? So that is one interesting point.
Yes.
And this is presumably due to bad imaging of the current telescope.
Okay.
But with ALMA, you can achieve very high spatial resolution.
Okay.
And you can study a very fine structure of molecular cloud. And hopefully we can get that kind of basic component of molecular gas, which has only thermal gas internal motion.
So in current technology, it's impossible to find some kind of the basic unit of egg of star.
Yeah.
So and you try to find it with ALMA.
That's right.
Wow, that's very fantastic. I hear that you have another hypothesis about some star formation.
Okay, star formation starts with molecular cloud.
Okay.
Then the molecular cloud is being condensed. Then you can form star and planet.
Okay.
But from the theory of thermodynamics and statistical mechanics, the entropy should increase. So, but apparently, the process of star formation is decreasing the entropy.
Yes.
Because it's just my personal question, but I don't understand why. So, if I could study this kind of entropy analysis, that would be interesting.
Okay. I think it's very interesting question, so I hope you can elucidate it someday. Thank you. So the last topic, we move to the last topic. To achieve your future research, what kind of resource do you need from other
Okay,
researchers?
as I said, I'm interested in the entropy of molecular cloud and star formation. So I need help from such kind of researcher, including physicist, statistical mechanics and thermodynamics. If those kind of people can give me their advice, that would be great.
Thermodynamics is very important because the molecular, the star formation is the process of molecular movement. So I think very important. Okay, and do you have any?
Okay, and next important point is I'm interested in planet formation. And when planet forms, you may have the Earth.
Yes.
So that means you may have life.
Life.
Right. So
Life.
I'm interested in the origin of life.
Oh, wow.
So the origin of life is it's a kind of chemistry, organic chemistry.
Yes.
So I'd like to I'd like to discuss with those chemists, chemical people who is working on organic chemistry.
Okay.
And really, the basic component of life is considered to be amino acid.
Amino acid.
Right.
Yes.
And that's why some people is trying to find the amino acid in industrial space and the molecular cloud.
Okay.
So if we could get some advice, that's
So,
what it is.
if there is some chemist who is interested in the origin of life and studying amino acids, something, please tell me. Okay. So thank you very much. This is all of our interview. See you next time.